Good evening, students. Welcome to one more session of your WOC, that is World of Chemistry. The students who have joined new to this channel and the students who are watching, who are there with me since 3 years, right, good evening again. So here, as I have to tell you, compared to the last year students, this batch students are very lucky. If I have to tell you, I understand. You have that tension when which exam will be there or not there. Leave that all uncertainty. Feel happy. You're getting extra days for preparing. Yes, students. So we as educators, for making one particular video, we really put in 100% effort. So we as educators, we expect you all to watch the video, share it, and if it reaches more and more number of students, as an educator, we feel happy, right? So as I said, I have started with the inorganic series where I did D and F block questions, coordination compound questions. I did, ionic radii, ionization enthalpy, atomic radii, mock tests also. Like that, inorganic series is going in full swing, right? So, and next important, as we know, in inorganic, different chapters are there, very important for your exam. That is chemical bonding, SPDF trends, equilibrium, electrochemistry and physical chemistry. Like that, all these chapters, they, compulsory questions will be given either based on trends or based on the, increasing and decreasing order, something like that. And next, they'll be asking you to solve the question. Time is less, but for that you need some trick to solve the question, correct, isn't it? So whenever I put a thumbnail or when I put a title, trick for coordination compound, compulsory the video will have certain amount of tricks for you all. So please watch the complete video, right? So today the topic which I have chosen, the important chapter, that is your chemical bonding. So chemical bonding is a chapter. As I said, in chemical bonding, I have already taught 100% of the theory which is kept in the playlist, right? So everything I have done in chemical bonding and kept number wise. Today I am going to teach you the tricks for solving the important questions based on covalent character. I'll be doing the covalent character questions, how to solve it. I'll be doing questions based how to solve ionic character questions, bond parameters, that is bond length questions, bond order questions, bond angle questions, polarizing power questions, I'll be also doing question based on hybridization. I'll be doing question based on your dipole moment. I'll be doing question based on hydrogen bonding, right? So like this, all the concepts of your Vesper theory, VBT theory based on your chemical bonding, I'll be first giving you the trick for each concept. So what possible options or what trick you need to remember in that concept, I'll explain. After that, whatever are the relevant questions, so question will be given and an answer solved away will be done. So for all these, little bit the video duration will be long, but after doing all these, after understanding the trick and solving the questions, you will have a clear idea, okay, when stability question is given, I have to apply this trick. When polarizing power question is given, I have to apply that trick, right? So let us come and start with the first concept, covalent character, increasing order, decreasing order, what it is, let us understand. Trick as well as question and answer from my side. Let's start the video. Right, now let us start with the first concept, that is covalent character. Here I have taken 3 different examples which you'll be asked quite frequently, right? If you understand the concept here, you can apply this concept in any question which is given based on covalent character, right? So this is basic Fajan's rule which I am using it. Let's see. What should you remember? Whenever covalent character question is given to you, 3 concepts you need to remember. What is that? Remember, higher the charge of cation, okay, higher the charge of cation. So instead of writing the sentence, let me put like this, in this arrow, higher the charge of cation, okay. covalent nature, covalent character or covalent nature or character will be more. So the first one is over. So charge is higher means covalent character is more. Right. Next, what should I remember according to the Fajans rule? The next one, the smaller the cation. So cation is smaller. If the cation is smaller, anion obviously that is your larger anion. Smaller cation, larger anion. This is also over. If the cation is smaller, simple thing you need to remember, the covalent character will be more. Done. Let me draw this line. If the anion is larger, again the covalent character will be more. Remember, simple, isn't it? Smaller cation, larger anion. We know that. Covalent character more, covalent character more. So here also charge is more, cation charge is more, covalent character is more. So simple. What should I apply in this? Now I'll remember all these and go to the exam and apply the same. If the charge of the cation is larger, we said. Now we have in all these three salts, we have cation different, cation different. What is similar? Anion is similar. For me, that's not the problem. Now I have to see the charge. If I take the sodium chloride, this is Na plus. This is magnesium plus 2. Aluminium is aluminium plus 3. Simple as that. So here I said if the charge of the cation is more, covalent character is more. Now simple. Charge of the cation is this. Which will be more covalent? Aluminium chloride is more covalent compared to Na. Let us rewrite. NaCl, if I to say this is ionic in nature, less magnesium chloride intermediate, less aluminium chloride AlCl3 covalent in nature. Simple, isn't it? I have applied the first rule to this. So NaCl is an ionic compound, aluminium chloride is a covalent compound compared to NaCl. Okay, right. Now when I take the next one, let us apply this concept here. We said smaller the cation, covalent character should be more. Smaller the cation, let us check. Here all anions are similar, only is cation different. So the cation here is barium, here the cation here is magnesium, cation here is calcium, cation here is beryllium. So what should I remember? Cation should be smaller. Among all, which one is a smaller cation? Beryllium. So beryllium comes here. So beryllium is what? It is more covalent in nature. So beryllium is covalent character is highest maximum. If I have to see which is the largest cation among this, beryllium, magnesium, calcium, barium. So barium comes here, barium chloride. So barium chloride is ionic in nature according to this, because the cation is larger. I said if it is smaller cation, it will be covalent. Larger cation, it's ionic rather than other way around. Right. The next one, if I have to compare magnesium and calcium. So this is larger. Next one is which one? Calcium chloride. Next one is which one? Magnesium chloride. And next one is beryllium chloride. So beryllium chloride is covalent in nature. Barium chloride is ionic in nature. That's done. Let us compare this. We say anion should be larger, covalent character will be maximum. Now we will see. Here cation, all cations are similar. Nothing to bother. For us in the exam, if they give anions are, we have to see this. Now among these, calcium fluoride is a smaller anion. Calcium iodide is a larger anion. So I said anion should be larger. Let us write the order. Calcium iodide is more covalent. What is the reason? Just now we have written anion larger. Among all these, fluorine, chlorine, bromine, iodine. Iodine is a larger, so more covalent character. Which will be more ionic? As I said, calcium fluoride will be ionic in nature. Why? According to Fajans rule, anion is larger means it is covalent. Anion is smaller means it is ionic in nature. Now let us rearrange. What is left? Fluoride is over, iodide is over, then comes calcium chloride, then comes calcium bromide. So if I have to write in this way, lesser, lesser, lesser in this direction, isn't it? So this is clear, students. Simple concept, nothing to get confused. Remember this, apply it. So whenever covalent character questions are given to me, I have to remember charge should be higher of the cation, size should be smaller for the cation, anion size should be larger, then only covalent character will be more. Now let us come and do the next important question, very interesting, about the next example in your chemical bonding. Right, so let us come and do the next topic of your chemical bonding, that is your bond length and bond angle. That here they have given me a question, arrange the following in the increasing order of their bond length and bond angle. What should I remember here? The basic concept you should remember is bond order is inversely related to your bond length. Done. Next concept, bond length is inversely related to the bond angle. If this increases, this decreases. If this increases, this decreases. Let's see whether I am correct or not. Here they have given me this question. As soon as this is given, just let us write structure quickly. NO2, this is your plus. What is the shape of the molecule? It is linear in shape. Whenever it is linear, the bond angle is compulsory 180 degrees. Yes. Now when I take the second one, NO2 in this way, oxygen minus. What is the shape of this molecule? This is a bent molecule. Done. The shape of this is bent. So this the bond angle is 132 degree. In this case, NO3 minus oxygen 1, double bond oxygen, 3 oxygens. Done. Here the shape of the molecule is trigonal planar. Trigonal planar. The bond angle is 120 degrees. Done. Now, say next bond angle is over. Now I have to write bond order. Basically, I'll teach you a small trick on bond order in the next 5 minutes. So as of now, I'm directly writing the bond order. For bond order for NO2 plus is 2. This is 1.5, this is 1.33. This is over. Now I have to apply it in the question. How should I do? As I said, see for which one is the bond order more? Bond order is 2, 1.5, 1.33. Now what did we say? If the bond order is more, bond length will be less. Now let us answer this question. Bond length order is according to the increasing order. The whichever has bond order more, its bond length is less. Bond order more, bond length is less. Let us write. So NO2 plus will have less, bond length will be lesser compared to next one NO2 minus compared to NO3 minus. This is done, students. This is over. Simple. Now I have this is over. Now I need to write in terms of bond angle. Now what did we say? Simple. Bond angle and bond length are inversely related. You can only check. See here. Bond angle is 180 degrees. Right? So here 132, 120. Now when I take NO2 plus, this is, let us write this here directly. It is 180 degree bond angle. Next comes 132 degree bond angle. This is 120 degree bond angle. Now you only say whether it is reverse or not. See here, angle and length are reversed in this one. The one which has lesser bond length has more bond angle. The one which has lesser bond length has more bond angle. Correct only, no? So how should I write the order in this way? Bond angle increasing order, the maximum would be, that means NO2 plus will have more bond angle greater. The minimum will be NO3 minus. So NO3 minus is less than NO2 minus, which is less than NO2 plus. This is clear, simple. This thing I have applied in this question. That's all. Let us check, recheck. This one, the bond length compared to this, from the bond order I got more bond order, less bond length, more bond angle. Simple as that. Right, students, let us come and do the next concept, that is your hydrogen bonding. So what should I remember in this? Let's see. Remember hydrogen bond strength. So they may ask you in this question, they either ask you, okay, let us not write the order first only, let us see whether we can justify it or not. From here I need to find which is having more hydrogen bond strength, right? So remember, hydrogen bond strength, if I have to see, it's directly related to the electronegativity value. If the electronegativity value is more, hydrogen bond strength also will be more. And it is inversely related to the size of an atom. Okay, how can I apply this concept in this? Let's see. When I have to see among all these, hydrogen electronegativity value is 2.1, fluorine is 4. Okay,
Hydrogen again is 2.1, oxygen is 3.5. Here when I take hydrogen is 2.1, nitrogen is 3.2. Hydrogen is 2.1 and chlorine is 3. Now, among all these, fluorine has the highest electronegativity and chlorine has the least electronegativity. So, the bond strength, this will be maximum because both are directly related. This also maximum, this also more. Simple, isn't it? So, I have applied that concept. So, in the exam, as you see, directly if they give you, you can apply the concept and solve the or put the tick in the correct option. Right. So let us come and do the next concept based on the stability question. Right. So here, remember, such question is given to you. They've asked you to arrange according to the or increasing order of their stability or decreasing order. No problem. Let us. It's okay. Anything they give, concept you need to understand. Here, suppose in this question, I need to understand based on their electronegativity. Why? Because whenever you have stability questions, you should compulsory remember most electronegative element. Okay, if the electronegative element is more, means the electronegativity value is maximum, the stability will be also maximum. Remember, stability is maximum. If the electronegativity is maximum, stability maximum. So if I have to see among all these which has maximum electronegativity, fluorine. So fluorine has the most, it is most stable if I have to say according to this concept. Done. Among everything which is least stable, so let us write this one, stable since electronegativity is high, that is 4 is electronegativity. Done. Let us come back. Here among all these, this has carbon has least electronegative, so least electronegative atom, that is carbon, so more, that is unstable in nature, right? So it is unstable and that is stable, right? When I have to compare both these two, next comes nitrogen in the picture, less stable. After that comes, compared to these, fluorine is over, least is next, oxygen, because of its electronegativity. Now see, least electronegativity, then next comes nitrogen electronegativity, then next comes oxygen, then fluorine is maximum. So what is the concept? Whosever electronegativity is higher, the stability of the negative ion will be more. Now, one more concept you can remember. Whenever there are, there is no resonating structures. Let us assume like this. Suppose you have something like carbon, double bond O. There is one more like this, plus, and your carbon, this is minus in this case. So if I have to compare these two stabilities, simple, the one which that is resonating but which doesn't have any charge is more stable. Compared to this, the one which doesn't have charge is more stable compared to one which has charge, right? So this is how you need to remember. So whenever stability questions are given, understand or remember this concept, go and check the electronegativity value and finish off the answer. Right, now let us come and do one more question based on polarizing power. So on polarizing power question is given. Here there is one certain question given with charges. Let us analyze how to do. So whenever this sort of question, arrange the following or take the correct order of the polarizing power, such questions are given to you. Remember again the same Fajans rule I am applying. Smaller the cation, right? One concept. Higher the charge of, higher the charge, that is a positive charge which I am talking about on these cations, right? Higher will be the polarizing power. Higher will be the polarizing power, right? So now among these, which is the correct order if I have to see? So which is the maximum charge? Aluminium. So aluminium, wherever aluminium is there, that is where you need to see. So higher is a charge, higher is a polarizing power, I said. So among all these, aluminium is there in option A and aluminium is there in option D also. Right. Next comes here I compare magnesium same, potassium cesium. Now we very well know cesium francium, all these are radioactive materials. They are not going to react. That is why when I have to speak which is more polarizing, this option is the correct option because of this radioactive material. So here this comes cesium, then come potassium lesser, magnesium lesser, aluminum is maximum. So please try to apply this concept in this. So the first option, aluminum will be having more polarizing power compared to cesium. Right, now let us come and do one more question based on the concept of bond order. Right, so basically bond order, I'll give you a trick here, just remember. So normally if I have to see the definition of this one, bond order is nothing but total number of atoms by, in the particular structure, by total number of resonating structures. Okay, total number of resonating structures. Okay, so here in the exam it's very difficult for you to keep checking, drawing the structures and everything. So one trick for you all, remember. So I'll erase this and just see, I'll give you one important thing. What is that? Simple, whichever structure is given to you, you need to calculate the bond order. Follow this step. Step number 1, that is, first you calculate the total number of electrons. So to calculate the total number of electrons quickly, you can know atomic number. If you know number of electrons, you can easily predict. After that, quickly what you can do, you after getting the total number of electrons, you're going to subtract that from 14. Subtract it from 14. Done. So once you get that answer, you're going to use this formula 3 minus 0.5 into n. So the subtracted number you will be writing in this n. Let us do what I tried to tell you. For the first one, it is n minus 2, 2. What is the total number of electrons? Nitrogen atomic number 7. So 7 is the number of electrons. 7 into 2, 14. So there are 2 electrons extra. So plus 2, it comes to 16. First step is over. In the second step, you subtract it from 14. So 14 minus 16. So it becomes minus 2. Then you are going to the third step. 3 minus 0.5 into minus 2. So according to the board mass, you solve this. You get an answer of N2 minus order is, if you take 2.5, okay. So it's nothing but 2. Yes. Done. So same procedure. If I have to do for the next one, I'll erase this, and the same thing for next one, that is N2 minus, same thing, 7 into 2, 14, minus 1 means add 1 electron, 15, 14 minus 15, applied in the third step, 3 minus 0.5 into 1. So this comes to 2.5. If I have to do the next one for nitrogen, number of electrons, for 1 nitrogen 7 electrons, 2 nitrogen 14 electrons. So 14 minus 14 is 0. I'll apply in the third formula 3 minus 0.5 into 0. What is left out? Nitrogen, the bond order is 3. Simple, right? So I have got 2.5, I have got 2, and I have got 3. Right, simple, isn't it? So what did we get? We have got 2.5, we have got 2, we have got 2.5, we have got 3. So the correct order, they said, which among the following is the correct increasing order, the bond order? This is correct. The first option is the correct option, right? So this is how you're going to calculate. Simple, nothing. Again, I'll just repeat it. Whatever is the total number of electrons, write it. So for 1 nitrogen, it is 7. For 2 nitrogens, it is 7 into 2, 14. Done. After that, you're going to subtract from the number 14. I get 0. Then I'm going to substitute with 3 minus 0.5, n, that is n value is 0. Finally, I have got 3. The bond order we very well know, no? Nitrogen, triple bond n. This is a bond order. So this is how you need to calculate and quickly put a tick to the right answer. Now we will take one more example, that is with oxygen, and it's easy, simple. Use the same bond order formula for that, apply it and tick the correct answer. But there oxygen, it can be oxygen atom, O minus 2. Let us see the example and do the correct or tick the correct option. Right, now let us see among all these given oxygen atoms, what is the order? Some simple logic, as I said, use this formula and we can directly write the order. So I'll show you one example. Oxygen, number of atoms are 16, correct? Done. There is no valency now, no charge on this. Directly take it and go to the next step, subtract it and you'll get minus 2. This is fine. Then apply it in the third step. This is 3 minus 0.5. Number of electrons is this is minus 2. So when you solve this, you get the oxygen valency or the bond order is 2. That's why oxygen double bond O. Like that, when I solve everything, we get the bond orders like this. Oxygen is 2. O, the second option is 2.5. The third is 1.5 and the fourth is 1. Now simple. Same thing I have applied in everything. If I have to write the order, the correct increasing order according to this question, the highest is which one? The increasing order means the first thing should be the less, the last one should be the maximum. So here 4 is minimum. Okay, no problem. So 2 is there, 2, 2.5, 1.5 and this one. So the least one, if I have to write, 1 is least. Okay, so 4 is less than. Next come to 3. 3 is less than 2. 2 is less, okay. 3 is less than 2. 3 is less than 1. I'm sorry. 3 is less than 1, less than 2. Let us see. Now the fourth one is 1, that is O2 minus. Let us write O2 minus. The bond order is 1, it is lesser than 3, that is O2 minus. Done. Which is further less than oxygen, which is further less than O2 plus. This is the order. Simple, isn't it? Use the bond order technique and try to solve this question. Right, now let us come and do or solve one more question based on your bond angle. So what should you remember in bond angle? Let's see. So always remember in terms of hybridization, if you speak, the bond angle in terms of hybridization, right? So sp will be greater than sp2 will be greater than sp3 greater than sp3d. In that way it carries on, correct? Right. The next thing or next concept which you should remember is, as the number of lone pair increases, the bond angle also increases. Remember that. Next clue which you should remember is, if the lone pairs are 0, means there is no lone pair in the structure, bond angle will be same. Means the bond angle will be same. There's not change in that. Let us see in this question. Right. So here, and next important thing, fourth important thing which you should remember is, see, suppose there is one atom like this. In this way you have atoms, so B, C, D, right? This is the central atom, these are the side atoms. Now I'm going to give the concept in this way. Just see, if the central atom, this one is different, if the central atom is different, I'm giving this, and side atoms, this, and the side atoms are same or side atoms are similar, then what will happen? Remember this thing, when the central atom is different and the side atoms are similar, your bond angle is inversely related to the size of central atom. Next concept which you should remember is, I'm writing the fifth concept here in the same way. Here we have written central atom different. Now I'm writing, if the central atom is same and the side atoms whatever are attached, side atoms are different, then what will happen? Remember, your bond angle is directly related to the size of side atoms. All these concepts will cover all the bond angle questions. So with this concept, I think you can almost rather all the 5 options you can use it for solving the bond angle question. Right. So here let us solve this now. Here I don't have any information. Only thing I have is, on these particular thing there is charge. Now as soon as that thing is given, which one to apply? Hybridization, I don't know. Like, I think the second concept, that is lone pair, I can apply. I'll take that and draw the structure NH2 minus. Draw the structure. Nitrogen is here. One hydrogen on this side. One hydrogen. How many are over? 1, 2, 3, 4, 5, 6, 7, 8. And minus is already there. Next structure. Now how many lone pairs are there? There are 2 lone pairs. 1 and 2. If I have to take the next ammonia structure, ammonia, N, hydrogen, 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 count 1, 2, 3, 4, 5, 6, 7, 8. How many lone pairs are there? 1 lone pair is there. When I take the last one, that is NH4 plus, let me draw the structure. Nitrogen, hydrogen, 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 and one more hydrogen and plus. How many lone pairs are there? 0 lone pairs. Simple. Come back to the option now. Just see. So here NH2. Now they said which is correct in this. Okay. NH2 minus is greater. NH2 minus is greater. Lone pair. This option is correct here. First option. Because remaining all are wrong. NH2 is greater. 2 lone pairs. Done. It is greater than ammonia. Ammonia 1 lone pair. That is also correct. Then NH4 plus is 0. That's also correct. So the correct option is this one. Isn't it? So what did we do? We have solved it on basis of more number of lone pairs, more is the bond angle. So you can use options 1, 2, 3, 4, 5 for different bond angle questions. Now let us come and do a question based on dipole moment. Right, now let us come and see the next concept, that is question based on dipole moment. So I did a video what actually is dipole moment, what actually is mu, what is d by, what are the different values you need to remember, how do we calculate magnetic moment, how do we calculate dipole moment, like that. I did everything and kept in the playlist. Please check that video, dipole moment. Right, now here we will see what are the techniques or trick what I have to remember during exam. Right, so basically dipole moment, when I say, remember, dipole moment is directly related or directly proportional to the electronegativity difference. If the electronegativity difference is more, automatically dipole moment will also be more in that particular molecule. Done. The next concept which you should remember is the dipole moment is directly, or if I have to say this one, the dipole moment in terms of your lone pair. So if the number of lone pairs are more, okay, if the number of if you see, to draw the structure and see, if the number of lone pairs are more, then also dipole will be more. So directly related. Done. One more concept is your dipole moment is inversely related to 1 by theta. See, when you have an substitution, the ortho position, para position, meta position, that angle what is there, that is inversely related to dipole moment. If this increases, this decreases. Done. Right. So based on this concept of this particular basic trick, let us apply this in the question and see. Here they have given me arrange in order of increasing dipole moment. Done. So here important, first thing, the least one should come first and the maximum more dipole moment should come in the last. Done. Here among all these, what are you observing? Highly electronegative element, fluorine. See here, more is the electronegativity difference. So this is 2.1 is this is 4 is electronegativity. Here hydrogen is 2.1. Correct? We have written this one. This electronegative values also. Just see, among all these, among oxygen, sulfur and fluorine, fluorine is the highest electronegative atom. Correct? Right. So among this, as I said, as electronegativity difference increases, dipole moment also increases. Done. So the first one is BF3. Done. After that is, what is the next one which comes? Among sulfur and oxygen, which has more electronegativity? This is. Then again after this comes oxygen. Simple, isn't it? So BF3 is Okay, ma'am, why you're saying in terms of BF3, I'm getting confused. One more thing also I'll tell you. Here in BF3, the molecule is linear or the molecule is symmetrical in nature. Exactly, the BF3 molecule is symmetrical, right? Okay, so here in terms of symmetry, if I see the structure is symmetrical, then also dipole moment is 0. What? The one more concept which you should remember is the structures which are linear in nature, the structures which are tetrahedral in nature, the structures which are trigonal in nature, okay, the molecular structures trigonal in nature. So remember, for all these the dipole moment would be 0. But there is certain exception like SF6 which has distotal tetrahedral structure, distotal structure. Because of that it has permanent dipole. That is an exception. Next important thing, structures which are angular in nature, structures which are seesaw in nature. Such structures they will possess certain value of dipole moment. Remember that. Okay. Now I am applying this concept here. So according to the electronegativity value, fine. This is almost 2.2. This is more than that, 3.3 or something. Now according to this concept, BF3 is a symmetrical molecule. It is a symmetrical molecule. So for the symmetrical molecule, if I have to say the symmetrical molecule, what happens? The dipole moment, as I said, is 0. So the dipole for this, according to this, is lesser. Next comes sulfur and oxygen. This is compared to this, the electronegativity is more. The difference is more. So this is lesser than this. So here the electronegativity difference of oxygen and hydrogen is more compared to sulfur and hydrogen. That is why directly related, the correct order given or the correct order is this. Let us come into one more question. Right, now let us solve this question based on this concept. Here they've asked me to arrange according to their decreasing order of the dipole moment. Means they've asked me which is the maximum dipole, which has the maximum dipole. Let's see. I said the electronegativity difference more means dipole also would be maximum. Here are the electronegative values. Just see. Now as we know, hydrogen is how much? 2.1. Okay. Now here carbon, because this bond here it forms in this way, isn't it? Carbon, 3 hydrogens are there and you have iodine also like this. So I am finding or writing the difference between carbon and iodine. So here carbon is 2.5 and iodine is 2.2. Here carbon is 2.5, bromine is 2.8. Here carbon is 2.5 and fluorine is 4. Here carbon is 2.5 and chlorine is 2.9. Whose electronegativity difference is more? Carbon and fluorine. So this will be maximum. Then comes CH3Cl less. Then comes CH3Br less. Then comes CH3I less. Simple, isn't it? See the difference? Carbon also 2.5, this is 2.2. So larger the electronegativity difference, more would be the dipole moment. So this will be more dipole moment compared to CH3I. Here less dipole. We can speak in terms of bond length also. Shorter the bond length, longer the bond length also. Let's see 2 more questions on dipole moment. Right, now let us again do 2 more questions based on this concept. Here what do they give us? Which molecule has 0 dipole moment? Okay, so here I think in the last question I have applied this. Now let us see one more which I can apply the structure. Right, so here we said linear, tetrahedral and trigonal will have 0 dipole moment. Right, exceptions are still there. Now among all these molecules, which is a molecule which has linear structure? Carbon dioxide. So carbon dioxide is a molecule which have 0 dipole. Simple. Let us come and see here. Which molecule has largest dipole? Again the same thing. When they say largest dipole, your concept should directly go into this electronegativity difference. So here compared to chlorine, iodine, bromine and fluorine, the electronegativity or the electronegativity value value of fluorine is high. So the difference would be here 2.1 and 4. So the difference is maximum. That is why HF has the largest dipole moment based on this concept. Right. So these are the different concepts, students. So I have covered concept on stability. I have covered concept on polarizing power, bond length, bond angle, bond order, covalent character, ionic character, dipole moment, lot and lot. So like this, I think the trick and the questions which I have given you will really help you out. One important thing, remember students, here for making a particular video, we as educators, it takes a lot for us to do. It is not simply we just upload, copy paste and give it to you. For us, we want every student to be benefited, so we put lot of efforts. As an educator, I believe more than an educator, the students have to put more, I think 100 times more effort, because it is your future, isn't it? So please watch the complete video. I'll be meeting you next with a very important video, that is your DNA block trends and exceptions also. Wait for my next video. I think this is clear for you all. I request you to share to more and more friends, so that it will be very beneficial for your GE, CBSE as well as NEET examinations. So study well, stay happy.